We're going to solve exponential equations. So within exponential equations, there's really two ways to do this. They're both, graphing I think is easier with technology because you can put them into Desmos and find the intersection point, but that can sometimes be tricky to see it, so getting that to work. But common base is the more, I guess, mathematical or algorithmic way to do it, but that can also be very tricky if you can't find the common base. I recommend using like a chart with common exponents, like common bases, and then like them to various powers. You can kind of see in the example here. And the reason you want the common base is because when I get to it down here, I start out with, when I get to it down here, I have the same base, which means that if I have b to the y is equal to b to the x, so the same base, the property says that y equals x. So based on this, when you get to a common base, you can set your exponents equal to each other and then solve for x. I didn't show you all the algebraic steps here, but you end up with x equals -5. And so that's where they would intersect. You could find the y-coordinate by substituting back in. So here, 32 to the x plus 2 equals 8 to the x. You can make 32 2 to the 5th, and 8 is the same as 2 to the 3rd. So then using properties of exponents, I multiply a power raised to another power. You multiply your exponents. So 5 times x plus 2 is 5x plus 10, and 3 times x is 3x. Now, since I have the same base, I set my exponents equal and I solve for x. The strange thing here, though, is when I do graph it, the y-coordinate it gives me is not accurate. For example, if I did 8 to the -5, that would end up being 1 over 8 to the 5th. If I did 32 to the -5 plus 2, that would end up being 1 over 32 to the -3. So if we work that out, you'd end up with a small number, but it wouldn't be the coordinate that it was given to me when I graphed this in Desmos, which is not possible to have a y-coordinate of 0. So it said that it gave me the correct x-coordinate for their intersection. The y-coordinate itself was not a possible answer here. So this was basically what the graph looked like when I put it in Desmos. The way it was viewed, you couldn't see the y-intercept on this one. It ends up being really way up here off the graph, but you would just plug them in. And then the other tip for plugging these equations in Desmos is when you have an exponent, you can type 32 and then I hit shift 6. I had to put parentheses around this because every time I did x plus 2, it did put the plus 2 down here in Desmos. It did 32 to the x and then did plus 2, and that's not what I wanted. So I went back and I typed parentheses here, and it allowed me to put the 2 into the exponent. So that's just some tips for graphing it. But again, this is how I can solve exponential equations in 2 ways.